So let's move on with our last piece of lecture. I'm starting again with this topology. Why? Because I want to show you about the Nexus 1000V. The Nexus 1000V is located a little bit differently. Why is that? Because the Nexus 1000V is a software component. Or N1KV is the short name for it. The N1KV is a fully software-based product. There is not a single hardware deployment for this. There is a thing called the Nexus 1010, which is basically a C-series server which hosts a number of VMs, and one of them can be a Nexus 1000V. But that's not in the scope of the lab. Nexus 1000V is a full software component. What does it do? In the past, I had ESX servers. I'm going to focus on VMware because that's what we're running in the lab as well. So in the lab, we are running ESX on our B200 blades. So in the UCS chassis, these B200 blades, they will run VMware ESX. You might be booting 1, 2, 3, or 4 blades, depending on your lab, of course. So you're running ESX. On that ESX, in the past, we had to configure a vSwitch, remember? And we had a separate vSwitch per ESX host. Now that doesn't scale very well because we had separate configuration for each of the vSwitches. So we don't want that anymore. We got rid of the vSwitch per host. What we do now is we take one controlled configuration and we call that a distributed virtual switch or DV switch. We have a single configuration for all of the ESX hosts that are part of it. In that distributed switch, I can move and migrate VMs and create VLANs, and all the configuration is applied across all of the blades. So that is one way to configure it. Or at least there are two options there. I can run the normal VMware distributed virtual switch, but that one is limited until 5.1 in terms of features. Since 5.5, the VMware improved their distributed switch, and because they improved it, we have a lot of more features right now. So we can do more things. But of course, this is a Cisco test, so we focus on the Cisco version of this. VMware opened up an API for this, so that means that Cisco wrote a distributed virtual switch to run inside VMware ESX. So my VMs are hosted here in ESX, all kinds of virtual machines. And all those virtual machines have one or more network interfaces into the distributed switch. And they want to access the network. So I started here with, we have our VMs, and all those VMs, all the network connections in the VMs will get access to the distributed switch. They will point their connection towards the distributed switch and go out on a local uplink. Now, this requires, of course, first of all, some software being installed on the ESX host itself. So we install a plugin written by Cisco. So a plugin or a driver, as you can call it, we update that. So we replace the virtual switch in the ESX server with a Cisco switch, with a Cisco plugin. That plugin on the ESX host is called the Virtual Ethernet Module, or VEM. Every ESX host contains a VEM, and a VEM is comparable to a line card in a modular switch. So if I insert a line card with some ports in a switch, I see that as module 4 or 5 in the configuration. The same accounts for ESX. ESX sees a line, or Nexus 1000V. Nexus 1000V sees a line card showing up in its configuration, and that is an ESX server, and that is that VEM. That is a plugin. That plugin is installed either through CLI, so just SSH into the ESX server, copy the file and install it locally, or the more nicer way is use VMware Update Manager. Just install that plugin through Update Manager and that gets pushed to all the servers. You can do this up front, so I can install that plugin on every server I want. If I do not activate it, fine. So what I usually recommend is just install the update or install that thing through the Update Manager so you have it installed. Because the nicest thing to test is, the Nexus 1000V is free currently. The Essentials version, so there are two versions, the Essential version and the Services function or something like, or the Advanced version, sorry. So the Essentials version and the Advanced version. The Essentials is free, and the Essentials can basically do everything except firewalling. So there is a firewall feature set available for the 1000V. It's a little bit different, called differently, but that's where you need the license. For anything else, it's free. Download it from the Cisco website, download all the files, and run it in your local home lab. I'm running it in my home lab, and that's where we will be doing the demo. So it's free, so perfectly for running in your home lab. So that VEM installs on ESX servers. Now we need something to control that with. So apart from having VEMs, I also have a virtual supervisor module. Or VSM. The VSM is where I am running NXOS. I'm just running the same NXOS as on every Nexus. Running a Kickstart image, running a system image, software upgrades work exactly the same way, apart from rolling out the VEMs, of course. So the NXOS CLI is just available to you. I configure interfaces like I'm used to. I'm configuring radius like I'm used to. Everything is what I'm used to on the Nexus. I can copy and paste configuration from one Nexus to a 1000V. This VSM is just a virtual machine. I can run the virtual machine inside an ESX host that is also running the distributed switch. So if I have ESX servers, they are running that distributed switch. I can even run my VSM as a VM here. And that VM will still be able to contact the outside world just through itself. Remember, this is the 1000V and it can access the network going through itself. At some point you need to let go what is a virtual and what is a physical link here, but I can host that VSM inside an ESX server. It can be any server, any ESX server. Of course, I run that twice because I want to have two supervisors, right? Of course, with DRS affinity rules, I need to keep them apart so they never share each other on the same host. So vMotion never puts them on the same host and stuff, but you will know the drill for that. So I'm running two VMs in my network to run all of my the configuration for the Nexus 1000V. That VSM is a VM with 3 connections. It has 3 network interfaces. So if you read any installation guide, it will say the Nexus 1000V requires 3 VLANs. That's not very true. I at least have 3 network cards in my system. I have a management 0 interface. This is just the IP management interface that I use to access the CLI of the 1000V. So this is just my plain management network that I'm managing every other device from as well. The second interface is called the control interface. The control interface is used, so this is just the management interface, and the bottom 2 interfaces are used to communicate between the VSM and the VEMs. So the VEMs on the ESX host are down here. Imagine there's a network in between, and we have those 2 interfaces to communicate to the VEMs. Because we need to talk to our line cards, right? The supervisor talks to its line cards. The control interface carries anything related to control plane packets, so like TCAM updates, any kind of control protocol, so hello packets, all kinds of stuff. The packet VLAN carries everything related to data packets that need to be forwarded by the VSM. So the VSM never forwards packets. It never forwards packets, that is for sure. So it will not do one port out, one port out. So like the CAT 6500 where some packets get punted to the CPU and that's processed there, the VSM will never process data packets. But it will receive data packets like LACP packets when I'm running port channeling, or ARPs for certain addresses. So there will be some data packets being forwarded, and they are using the packet interface. So these interfaces, of course, map then to a VLAN. So I have a control VLAN and a packet VLAN to send that traffic in. If I attach my VEMs to these two VLANs, the communication is established. So I need a communication path between the VSM and the VEM, and I can do that either through VLANs, so I have two VLANs, or just one. I can put these two interfaces in one VLAN if I wanted to. So running in two VLANs, the VEMs have access to those two VLAN numbers, or I can do it in a better way, and that is by using a layer 3 solution. Actually, more specific, a layer 3 multicast solution. The layer 3 solution is the more elegant way of doing this, and that's also the preferred way of doing that. That means that the VSM and the VEM can be worlds apart. Now, in this example, I have a layer 2 connectivity between the VSM and the VEM. If I have a layer 3 connection between the VSM and the VEM, it means I can place the VSM anywhere I want to. So that's why I said I go back to this drawing of the lab, because where is my VSM? My VEMs, so the virtual Ethernet modules, will be hosted here on a blade, right? Those will be my blades that are running ESX, and they will be running the VEMs. But how will they communicate towards the VSM? Because the VSM is not hosted on a blade. The VSM will run it will be connected to the backbone. So the VSM is running there connected to the backbone. And the connection between the VSM and the VEM is based on layer 3. It's just an IP connection between the two hosts. It does require multicast routing or multicast traffic for the discovery, but you will be configuring that. Or there will be a VLAN here. So there will be packets received here and then forwarded into a VLAN going down here. There will be some intelligent solution for this. So that's also where the cascading comes into play. If you do not configure your networking part correctly, if you do not configure the networking part in the UCS correctly, your blade's VEM will never register with the VSM. So that means that, again, you failed all the points. You lost all your points in the Nexus 1000V if you screwed something up here in the Nexus section or in the UCS section. So the communication between the VSM and the VEM. What do the VSM and the VEM need to exchange? Like I said, the VSM will never forward data packets. So all the forwarding is done by the VEMs. The VEMs will make the forwarding decisions. But they can only make forwarding decisions if they already learned about MAC addresses and that they know what the configuration is for those ports or all kinds of other things. So they will need to be programmed just as line cards with, for example, TCAM updates. So my MAC address table entries and every other entry that I need. So I need to have some communication there. Now what do I need to send? I need to have a control plane packet. So I need to send hello packets. Is my VM still there? Am I running the right stuff? And I need to send updates regarding my MAC addresses. And finally, there are some data packets that need to be forwarded to the VSM, like LACP packets and ARP packets, or any other data packet that you send to your switch. IGMP snooping, for example, is another thing. IGMP packets go up to the VSM. And then the VSM takes the forwarding decision and then programs that entry into the VM. Now I can do that in two ways. I can communicate between the VSM and the VEM. So I have all these VEMs here. I'm not talking about physical hosts, so this is just assume that I have 3 of those plugins running and I'm running 2 supervisors, so 2 VSMs. I will have an active and I have a standby. If I'm running the layer 2 configuration mode now, that's what I'm running here. I have a connection between the active and the standby VSM. That's running over the control VLAN. So I'm using 2 VLANs to separate the traffic. I'm using the control VLAN and I used a packet VLAN. The third VLAN management is only used to manage the Nexus 1000V. There are 3 solutions after this. So first of all, my control connection between the active and the standby VSM to exchange the configuration and exchange state. This is just stateful switchover, like on the Catalyst switches. Just normal stateful switchover between supervisors. The next connection are 2 connections. So the active VSM maintains 2 layer 2 connections, a control connection and a packet connection, to all of the VEMs or VEMs. This can be in 1 VLAN or in 2 VLANs. The recommendation differs per software version. Earlier versions said you need to spread this traffic across 2 VLANs. Newer versions say you can do it in a single VLAN. But there are 2 connections. Those 2 connections are both control and packet stuff. What I said is control frames are always related to the control plane of the switch. So sending hellos, sending TCAM updates, so administering the VM. Packet traffic is stuff like LACP, IGMP packets for IGMP snooping, ARPs, all that stuff. So data packets that need to go to a supervisor of a switch. This layer 2 connection means that if there is some hop in between, like a physical switch, I need to allow those VLANs on that switch. So if I start looking at the physical picture, I may have an external management server that is running my management VMs. For example, the VSM, right? That's one of my management VMs. And I have an ESX server that has the VM installed. Now there is a nexus maybe between here, a physical switch nexus. And that nexus has a connection to this server and to that server. Physical connections. This VM will have a lag in the control VLAN and in the packet VLAN. The red and the green VLAN need to be allowed on this link, so this trunk link going down to the nexus. So this is just the VLAN, the red VLAN is 101, the green VLAN is 202. Just 2 VLANs. And again, these VLANs need to go down on this particular uplink that I connected to the VM. And now I have my layer 2 communication. So allowing the right VLAN numbers is the only requirement for running VSM to VEM communication. So remind you that I need to allow these VLANs on an uplink towards my management server and towards the VM. How do I install a VM on ESX? because on my ESX server, I might have multiple NICs, right? So I may have, let's say, 4 NICs. NIC 1, NIC 2. I'm not talking about VNICs or anything like that. These could be VNICs, but it could be any physical network card. Those NICs are inserted into virtual switches. So I can run multiple virtual switches on my ESX server. So I'm running a standard virtual switch here, so a normal vSwitch, and I say NIC 1 and NIC 2, you belong to virtual switch number 0. That is a normal vSwitch. Then what I do to activate the VM is in my VMware configuration, I tell the server, so I'm doing this in VMware, right? I'm not doing this on a Cisco configuration file. I select this ESX server and I tell this ESX server, you are going to place NIC 3 and 4 into the Nexus 1000V. And that automatically initiates the VM. So NIC 3 and NIC 4 are now activated into the VM. And that is this connection. This connection is NIC 3, and I allow these two VLANs on NIC 3. So now I have my layer 2 connectivity between the VM and the VSM. I will run the layer 3 method of connecting the Nexus 1000V VSM to the VEM. So I can do that across an IP address as well. So now I have the same management server. That management ESX running the VSM virtual machine. Question, do we have access to the VSM console? Definitely yes. This is the one that you have access to the VSM virtual machine. Or console, you SSH into it. That is the connection that you have. And that's also everything you will ever need. Right, so this management server is connected to some layer 3 IP cloud. So based on IP addressing, I'm running maybe ERGRP or something to establish routing. Either way, I set up an IP address on the VSM. And on that IP address, let's call it 10.0.0.1. On that IP address, I want to communicate between the VSMs and the VEMs. Now, because I need to discover, let me first talk about the connection. That means that if I have my physical ESX server here, remember I have those two network cards, NIC 1, NIC 2. I set to them, you belong to the VEM. So I just configure that in the graphical interface, you now belong to the Nexus 1000V. And that immediately initiates the VM. That VM is a layer 2 module, right? It's a switch. It's not a router. So how do we get a layer 3 IP address configured here on these NICs? That is done using like an SVI type of interface on VMware that is called the VM kernel. A VM kernel port is just an IP port in the ESX server. So I configure here, I have my ESX server here, and I just configure a port that's called VM kernel, VMK. I can have multiple. That's actually the best practice. So I have one for management, I have one to do vMotions, I have one to do fault tolerance, I have one to do anything else. I have one for my storage connectivity on IP. So VM kernel ports have an IP address configured. So now my best practice, I configure a new VM kernel port just for the connectivity between the VSM and the VEM. So this is not part of the Nexus configuration, this is part of the VMware configuration. And here I say, all right, you have access to 10.12.0.1. That is his IP address. They can be in the same subnet, and they still talk on layer 3 then, or they can be in different subnets where they talk on the IP cloud. So that interface now has an IP address configured. And what I do is I tell this VM kernel port, I install you on this virtual switch. So I connect you to this virtual switch, and that is, by coincidence, that's the VM. I will show you in a minute how you do this, how this works in real life. So I say to this VM kernel port, you are going to run on that switch. Now that switch says, all right, hey, now I have an IP address. So now I can start using this IP address to connect to my VSM. And again, I connect my uplink ports here. I do not give them an IP address. I only have an IP address on that VM kernel port here. And that port is hosted here in the VM. So as long as I can ping from the VSM to the VM kernel port here, I will have connectivity. How do I establish that? Because it's IP, right? I cannot broadcast anything. I'm using layer 3 multicast. So the VSM will send out a multicast packet to a certain group, and the VM will listen to that multicast group. It will subscribe to that multicast group. And that is also the reason, if you have multiple ESX servers, so imagine I have 20 ESX servers here, I do not want to send a MAC address update for the TCAM to 20 different servers and send 20 different packets. I send one packet and it arrives automatically and at all 20 servers due to IP multicast. So I will show you exactly how that looks in VMware. How do you configure that IP address, and what kind of settings do I need to do to get this working? Because then if you see that happening, it makes sense how it works. This IP connectivity can be configured on two interfaces. Remember, the VSM virtual machine has three interfaces: control, management, and packet. If I use layer 3, I no longer use the packet interface. I still use the management interface, and I can use the control interface to do my layer 3 stuff on. Or I can use the management port to do layer 3 stuff on. But this, of course, the best practice here is use that control interface to run the IP connectivity. This will all be pre-configured for you. So if you configured your network correctly, if you configured UCS correctly, if you configured boot from SAN correctly, your server will boot, and once it's booted, the VSM should automatically see the VM coming online. That is pre-configured. But I need you to explain this because you might get the question to troubleshoot it, or troubleshoot but to fix the configuration. So maybe they are using the management interface where they want you to use the control interface, for example. No, that's not a valid troubleshooting point, but oh yeah, that is. So they could mess up with your configuration, and they will tell you then the Nexus 1000V is running in layer 3 mode. It's going to use the control interface to do the communication with an IP address of 192.168.10.2. Because this IP address here, I can configure that. The VSM has just an IP address configured here and there. So I could misconfigure the IP address in a different VLAN. So you will, in the task, they will give you these details. You log in and you see a pre-configured box. And then you need to check if those settings are correct. So that's why I also want you to know about the communication, how it works, and what it needs to work. So back to the layer 3 stuff. The best practice is using the control interface for my layer 3 connection, use the management interface for management traffic. The packet interface is no longer used. I do need to give this port an allocation because if I remove it, the whole box crashes, and I do not want that. but I'm not using that anymore. By the way, control management packet, that is the order of the adapters in the virtual machine. If you open up virtual machine settings, this is adapter 1, this is adapter 2, and this is adapter 3. Control management packet. Don't ask why this order is. I cannot change the order, this is the order. Now there is one more connection that the VSM has. So this is the layer 2 and layer 3 communication between the VSM and the VEM. There is one more configuration, or one more connection. And that is a connection to VMware vCenter. vCenter is the management station for VMware. And I need to work together with the VSM needs to work together with vCenter to get ports up and running. So in vCenter, I click on a virtual machine and I say power it on. Now, I need to say in vCenter to which network does this virtual machine belong. So in vCenter, I have an ESX server that is managed through vCenter. So this is just an out-of-band management box. It's going to program the ESX server. It's going to say, all right, this Windows VM, I'm powering it on. And this Windows VM, is part of network A. And network A happens to live here. Network A. That network happens to live here on the VEM. This information about network A is learned from the VSM. So from the Nexus 1000V, I learn what kind of networks it supports. And networks, I mean VLANs. And now, this Windows VM is connected to the network through vCenter. So vCenter arranges that connection that the VM is actually connected to the software switch, to the VEM. That is something that vCenter orchestrates. So therefore, I require a connection between the VSM and vCenter. They need to talk to each other. The VSM needs to tell vCenter what kind of networks it has available, for example. This connection is an HTTPS connection, so SSL. And the problem with that is the certificate. We need to exchange the certificate between the two. So this can be an IP connection that's running across the management connection. So it's running on the management port. And I need to exchange the certificate with vCenter. All right. So those are all the communications between VSM and other devices. Now, I assume that I'm running my VEMs are correctly assigned to the VSM, and I'm stepping into the CCI data center lab. UCS is perfectly configured. Everything works like I expect. And now I'm starting my task. So the task stated first what kind of connection was up and running. I checked that. I maybe changed some faulty configuration, and everything is online. Now, what do I have in my Nexus 1000V? Well, I just configure VLANs. I will configure uplinks. And I will configure access interface. So VMs. Now, because when I configure my VM, or when I configure my VSM, I'm unsure how many interfaces I will have and what VMs will connect to me, because that's something that vCenter is arranging, right? I'm not in control over the VMs. So in that case, what do I need to do to configure these uplinks and access interface without knowing them? We use profiles for that. Profiles are the basis of the Nexus 1000V. And the fun part is that the profiles is just an NXOS feature. So also in any NXOS deployment, I can use port profiles to build certain templates for all of my physical ports. So if I say I have 6 of the same servers connecting to my Nexus 5000, I could create a port profile setting switchport mode trunk, switchport trunk allowed VLAN 1, 2, 3, 4, spanning tree port type H trunk, and apply that profile to 6 physical ports. That is a profile in Nexus OS, and the Nexus 1000V is using that extensively. They are called port-profiles, and there are two types. I have an Ethernet port profile, and I have a vEthernet port profile. So I have physical port profiles, and I have virtual port profiles. The physical port profiles are used for my uplinks. So physical network cards in the ESX server, remember these guys, or maybe these guys, NIC 1 and NIC 2, these are my physical ports seen from the ESX server, right? These are my PCI network adapters that I insert into my server. So fun part on the UCS, these can be virtual again, but seen from the Nexus 1000V, they're physical, right? They're physical cards. And virtual means virtual machines. So virtual machines connect to virtual Ethernet port profiles. So what I start configuring, when I start configuring, what do I need at least? What is the minimum configuration I need on the Nexus 1000V? Well, first of all, that is the connection to vCenter. That's the first thing that I want to do. I need to set up the connection to my VEMs. What type? Am I using layer 2? Am I using layer 3? What kind of IP address? What kind of source interface? So these are the first two settings. Connect to vCenter and connect to your VEMs. Or at least prepare to connect to your VEMs. Then the third item is configure an uplink port profile. So before I can add a server to the VEM, I need to make sure that I can place these network ports into a certain profile. So I need at least one uplink port profile. Now, if I have my uplinks, if I have a server which has two uplinks, if I place these two uplinks in the same group, in the same uplink group, they will think that they are looping. They will tell the switch, I'm not sure what I'm going to do. I have two separate links on the switch. I'm not running spanning tree, so I'm lost. What do you want from me? I'm in a loop position. So this will not work. Your switch will be offline. What you need to do is, if I have multiple network cards in my Nexus 1000V, I need to port channel them together. I need to create port channels. This was one of the key features of the Nexus 1000V when it got released, because ESX was not able to do a lot of port channeling technologies, where the Nexus 1000V had a lot of options. So I need to port channel these physical links together. There are multiple ways to do that. If I'm running two NICs, this is my server, and this is just a switch. I do not care what switch. Not talking about UCS, just a switch. If I'm running, let's say, virtual port channeling here, so these are two Nexus switches and I'm running VPC between them, it means I can do this. And I can create an LACP port channel. This is something that the Nexus 1000V can do. I have my two NICs, I port channel them together, run LACP, all fine. But what if I'm running with two separate devices, like my Fabric Interconnect? Remember that VNIC is transported here to there and here to there. So this is the connection from my VNICs. How do I port channel these together? Because these do not run VPC. So I cannot port channel this on LACP basis. What you can do is port channel them together based on the concept of MAC address pinning. So it's not flow-based load balancing, but it will be VM-based load balancing. So again, another layer of port pinning in my network. If we didn't have enough layers of port pinning in between this path, right? I have my VMs, and each VM will be pinned to a certain uplink. And I will now load balance my VMs per link. That is the best practice for UCS. Use channel group mode on MAC pinning. That's the simplest way. There is one more way to do port channeling, and that makes it a bit more interesting. This can also be done on UCS. What if I have multiple links towards the same switch? And still doing this. So I have multi-switches and multiple links per switch. I'm still not able to do LACP. Well, I would be on these two links and on these two links, but not on the full port channel. So I can still not do port channeling. But what I can do is I can MAC pin to this group and to that group of ports, and then do flow-based load balancing on these two ports. Because these two ports can be port channeled, right? So what I can do here, this is not called MAC pinning. This is called something called subgroups. I can do subgroups. And what are subgroups is that subgroups create mini port channels within a bigger port channel. So I just create a big port channel interface, and underwater I will have mini port channels called subgroups. I can configure these manually by saying, all right, link 1 is subgroup 1. Link 2 is also belonging to subgroup 1. Link 3 is belonging to subgroup 2, and link 4 is also belonging to subgroup 2. So I'm going to manually configure these ports for 1, 1, 2, 2, and they will be bundled together. The next option I have is use CDP. I'm not sure if this works on the UCS, I've never tried it actually. But what I can do is if I'm running an uplink switch here and it runs CDP, then the Nexus 1000V will see that on these two ports, I see the same uplink switch. And on these two ports, I also see the same uplink switch. Based on that information, I automatically create a subgroup per switch that I detect via CDP. The manual way is of course a little bit more straightforward. But on the UCS, 99% of the times, even in the CCI data center lab, you will probably be configuring this MAC pinning. Again, because you're running the M81KR Palo card, so I only have left and right. I can do multiple VNICs, but there's no sense of doing that. So you probably only have two links on the blade, left and right. They will do MAC pinning. And I will show you how to configure that. So when I have more than one link on the server, I require a port channel configuration. Either with LACP, either with MAC pinning, or with subgroups. So, uplink port profile has been created with the port channel. Now, I would be done if I run layer 2. I would place links, physical links into that uplink port profile, and the communication would be established because layer 2 path is established. If I run layer 3, I need some other things. So all based on the VSM, right? This configuration is all done on the VSM. The fourth one is that I need a port profile for my layer 3 control traffic. That is a special port profile, a virtual port profile, so vEthernet. And the only connection that can be inside that layer 3 control port profile is that VM kernel port. And that VM kernel port is configured on the VMware server. So this is an item that I configure in VMware. What is the IP address? That's what I configure on that VM kernel port. So here I place my NICs, also a VMware configuration item. The VM kernel port, I need to place that into the port profile. I cannot do anything else with this port profile. Fifth port profile do I need? This is technically not necessary, but I need another virtual Ethernet port profile to host VMs. So I need at least one more virtual Ethernet port profile, otherwise I could not manage host VMs inside my Nexus 1000V. Because these ones are only for uplinks, this one is only for that VM kernel port, so these ones only belong to the system. And this is then my virtual Ethernet port profile that I'm really going to place VMs in. And then I'm done configuring the VSM. There's one more option that we need to discuss. So how do I configure a port profile? Let's configure one. Port profile type Ethernet. On that port profile I say switch port mode trunk. Because I probably want to trunk multiple VLANs outside to the outside world, right? I do not want to stay on one VLAN on my ESX server. I need to have multiple VLANs. So switch port mode trunk, allowed VLAN list, the normal configuration you would expect from an uplink on a switch. Channel group configuration. And then I have 3 commands that I always need to enable. Those are Nexus 1000V specific, or one way is no shut. That's, I need to no shut the port profile, so no shutdown. Then I need to say 2 special commands saying VMware port group to enable this group to copy that to VMware. That's what it says here. And I'm going to set the state to enabled. These 2 commands are specific to the Nexus 1000V. And I need them, I really, really need them, otherwise I will not see this port profile inside vCenter. I need these 2 commands. And I also need to have the no shut, otherwise I cannot set state enable. There is one special command. That is the system VLAN command. The system VLAN command specifies one or a range of IP addresses, or a range of VLANs, sorry. It's like a VLAN allowed list for a special range of VLANs. What is the special range of VLANs that I need in the Nexus 1000V? The concept of the VSM and the VEM is that, where's my VM kernel port? Here. When a VM wants to come online on the Nexus 1000V, so it sends a request to come online on the switch. So this VM here wants to come online on my Nexus 1000V. The VSM needs to create, or the VEM doesn't have the configuration yet. Because it's a new VM, it does not have MAC addresses in its table, it does not know the configuration. The VSM knows the configuration. So when the VM is powered on, the VEM will ask the VSM, hey, what's the configuration for this particular port profile? Because the VM will report its port profile. VM is going to ask what's the configuration, and the VSM will report back what the configuration for the port is, register the MAC address, and do all its magic. So the VSM is required when I bring up VMs. So changes to the switch, any change in connectivity on the switch has to be approved by the VSM. So every vMotion, because with a vMotion I enable the VM on another host, and with a power up statement, the VSM needs to approve on that. That is the very important thing here. The VSM needs to be running for anything to change on the switch. If both VSMs die, because we assume a redundant setup, if both VSMs die, I can no longer bring up connections on the Nexus 1000V. Any currently running connection, so any currently running VM, can still forward its packets. It is still able to forward packets, it's still able to transmit packets. But any change is not allowed anymore. So what I'm stuck in here is I'm bringing up my VM, right? So I'm bringing up the VM, and I said I communicate across an IP interface. That IP interface is just another host port in the switch. So before I can bring up my IP address on the switch, I need to ask the VSM about it. But I'm bringing up that connection, right? So I cannot communicate until I have access, but I can only get access when I communicate. So chicken and egg problem. Same accounts for what if I'm hosting the VSM. So the VSM virtual machine is hosted inside the same ESX. How will it activate its network interfaces? Because it needs to contact the VSM, but he is the VSM. So how does it communicate to itself? He cannot do that. So also for those two situations, we have a special command called the system VLAN command. The system VLAN command is configured on all the profiles that are related to bringing up communication between the VEM and the VSM. I need to bring up that connection between the VSM and the VEM to make sure that my connection is established. So how does that work? If I'm configuring my port profiles here for the Nexus 1000V, on my uplink port profile, I need to say, all right, allow that particular layer 2 VLAN, let's use for layer 3 control traffic or for layer 2 control traffic, allow that traffic here. So in my configuration, I'm going to allow in which VLAN is that layer 3 control packet sent or that layer 2 control packet sent. Allow that VLAN here. So system VLAN 1, for example, if my management VLAN is 1. Then that VM kernel port also needs very early access to the network, right? It cannot ask permission to the VSM because it needs to bring that connection up before it will be activated. So also on this port profile for the layer 3 control, I configure the system VLAN. Now when I connect normal VMs, I do not need it. So when I'm just connecting Windows VMs and all my other VMs, I do not need the system VLAN. And also do not put it there. Because what does the system VLAN command do? For that particular port, in that particular VLAN, it disables the packet processing of the VM. So the system VLAN disables the functionality of the VM for that port in that VLAN. So if I do this for normal VIMs, I would not have any benefit from the Nexus 1000V because I constantly punch holes to myself and said, all right, go through, go through, go through. I will not process you. So if a packet from that VM kernel interface is received, it says, all right, here, go ahead, go through. I do not need to ask permission to the VSM, but I do not process you. So that means every feature that I enable, like IGMP snooping or port security or private VLANs and stuff, nothing will work there because system VLANs are the gaps in the Nexus 1000V. So be very careful where and when to configure the system VLAN. And then I can start adding stuff to myself. Questions you might see in the lab are, let's say, you configured in the data center network, you configured a lot of VLANs, right? So you configured some VLANs there in the data center, and you need to allow those VMs to get access to those. You need to allow VMs to get access to those VLANs. So let's say you configured 8 VLANs on the Nexus part. Then if the question states make sure that the Nexus network is matching the Nexus 1000V, then it means configure port profiles for all the VLANs. Make sure the port channeling is okay. Make sure the communication is okay. Maybe even the QoS policy is the same. I can do traffic shaping in the Nexus 1000V, for example. So I can do queue reservations in the QoS policy and stuff. But that's advanced stuff. That's going to take a long time to cover.